This session is SVG, exploiting browsers without image parsing bugs, with Rennie DeReff. So thanks very much. Have a good afternoon.
Good afternoon, folks. Thank you for coming out. So this talk is about examining the security model of SVG and then various bugs that browsers have around that. I'm not going to be giving actual exploit code here. I'm not going to be popping calc or anything fun like that. That's for you guys if you're interested in that sort of thing. I don't do exploits. I just do finding bugs. So to start off here, let's give a brief overview of what SVG is. So it stands for Scalable Vector Graphics. It's an XML-based format for vector graphics as opposed to rasterized graphics. It's developed by the W3C. They're currently in version 1.1, which was published about 3 years ago, although the format dates back about 15 years. There's a version 2.0 in development, which has a bunch of new stuff and looks like it's going to have an expanded attack surface, but I haven't done any investigation on that yet. All of the major browsers support SVG natively, Internet Explorer being the last one to add support in 2011. But native support's been growing ever since about 2004 when Conqueror added it in. So SVG is a fairly simple format, at least if you're doing simple stuff, whereas that's all I really need for this. So here I have an SVG that it's a square box and it draws a circle in it. And the circle is gray. So when I render it, it looks like this. Nothing fancy. Art skills are not required for doing security research. There's a number of ways to use SVG in an HTML document. Obviously, since it's an image, you can do it with the image tag, or as a CSS resource, like background image or something. But you can also use SVG as a nested document using an object, embed, or iframe tag. And the static image contexts and nested image contexts are different, and we'll be coming back to that more as we go on. You can also drop an SVG inline into HTML5, which has some somewhat different properties that standards committees and browsers don't seem to entirely agree on yet. And then you can draw SVG onto canvas tags, and there's probably some other way to do SVG that I haven't thought of. There's a number of interesting properties that SVG has from an attack surface perspective. First off, you can apply CSS style sheets to it. So here we have an inline style sheet that changes the color of the circle to orange. Or we can do the same thing with an external style sheet. And we render it, it looks like this, an orange circle, woohoo. You can also script SVG with JavaScript. So here I have an inline script that puts a red border on the SVG. And of course, you can also do that with an external JavaScript file. And I render that, I get this. Next, you can embed external objects or external images into an SVG. So here I use an SVG image tag to embed another SVG, although I could just as well use a raster file there, like a PNG or something. The SVG's image tag is also considered a static image context, like HTML's image tag. So this one is, this image, it's half the height, half the width, and it's set at the center. So when I render it, what I get is a smaller circle overlapping in the bottom right corner. You can also embed HTML into SVG, just in case things weren't convoluted enough, using the foreign object tag. So here I've got a foreign object that contains XHTML, and inside that I have an object tag, or an HTML object tag, which links another SVG. So this is a way that I can get SVG as a nested document inside of an SVG. And when I render it, it looks the same as the previous image in image 1. It's offset. There's a smaller circle offset from the center. So since SVG can do just about anything that HTML can do, the attack surface is very similar. You can do XML attacks like your billion laughs or your various other entity-based attacks. You can attack the DOM using JavaScript. If there's any user input that's put into that SVG without being properly filtered, you can do XSS and all the other sorts of things that you're probably familiar with if you're familiar with web security. So here's an example with billion laughs in an SVG. So I define my big chain of lols that reference the previous lols. And then I have a text block at the bottom after my circle, which tries to instantiate lol9. Now, if the browser was actually to expand all of this, it would wind up with lol a billion times, hence the name, and it would bring just about any computer to its knees. So browsers and other agents that render XML are supposed to try to detect unnecessarily large entity expansion and error out. And indeed they do for the most part. If I load that document into Chrome, it errors out and gives me a big error message like this. In Internet Explorer, it detects an error, silently removes the entity, and continues on. Firefox, however, seems to be a little bit flaky. Sometimes it errors out immediately, and other times it sits there and chugs for a few minutes before it gives up. If I wanted to do a DOM attack using an SVG, so consider this HTML file. It loads a harmless SVG file from the same origin as the HTML using an object tag. And I draw a border around that just so we can see where the document ends and the SVG begins. And assuming that that's a nice, well-behaved, harmless SVG, this is all that happens. But let's assume that that SVG came from an attacker or was somehow influenced by an attacker, and it actually looks like this. So here I have the same circle file that I showed you before, except now I added a JavaScript in there that uses the top object to get a reference to the parent document, and then it starts scribbling on it by loading another image file from a different domain. If I render that, or if I load that, what I get is this, showing that we were in fact able to break out of the object and modify the parent. This is not anything fancy, this is normal expected behavior. For XSS, here's a PHP script, which again generates my same circle file, except this time I pull the color of the circle out of the query string. And I hope most of you can tell what I did wrong here. I'm pulling that color directly out of the query string without any form of sanitization or escaping. So if I do as designed and ask for a blue circle, that's what I get on the left. But if instead I ask for a bunch of JavaScript, well, it echoes that JavaScript right into the file, executes it, and I get pwned again. Again, this is by design. There's no design restrictions on XSS. So now let's discuss the security model around SVG. So like I said before, there were the two main contexts. If you have it as a static image, it's treated more or less like any other image format, like JPEG or PNG or anything like that. So in a static image context, it never loads external resources like style sheets or scripts or other images or anything like that. And it never executes any scripts, including inline ones. However, it does load inline style sheets and any inline data URIs. Instead, if you load the SVG as a nested document, it's treated pretty much just like HTML. It'll load external resources of any type. It will execute any scripts. Same origin policy applies. Sandboxed iframes disable script execution just like they do with HTML. And browsers need to be careful that when they're loading external resources, that they never load a document as a child of itself. So now let's get into some browser bugs. Internet Explorer has some issues with SVGs in static image contexts. In the HTML file on the right here, sorry, on the left, I load an SVG using the image tag. And inside that, I reference an external style sheet from the same origin. If I render that in Chrome, it behaves as expected. The style sheet is not applied. But if I render it in Internet Explorer, the style sheet is applied. Chrome is not blameless either. It has a similar bug. It'll also load that external style sheet, but only if it comes from a different origin. This bug, well, so if I render it in Firefox, I still get the behavior I expected, where the style sheet's not applied, but in Chrome it is applied. Now this one was fixed a few weeks ago, and I believe it was actually fixed in the most recent public Chrome build, build 36 or whatever they're on right now. Back to Internet Explorer again, it always loads external images, even inside the static document context. So here we have an HTML file that loads an SVG, and the SVG loads another SVG using an image tag. If I load it in Chrome, it behaves as expected, just a circle. But in Internet Explorer, it loads the circle and then tries to load the second circle. And it appears that there's a rendering bug there where it doesn't scale it down to half size, but whatever. It's not important right now. And now let's talk about recursion, or how to make expansion bombs. So as I said before, browsers need to never load a document as a child of itself. The way they do that is a check based on the URI. So as long as we can find a way to make the URI change at every iteration, we can build a recursive document. Now, the query string is part of the URI, at least as far as the browser is concerned. But if you request a static file off an HTTP file server and give it a query string, the server will ignore the query string. As far as it's concerned, every image with every file with the same name but a different query string is the same. But the browser thinks they're different. So we can try to use a client-side script to change the query string every time we reload our recursive document. Now we can't use SVG image to load the nested documents, because that's a static image context and we don't run scripts there. So instead, we'll put a foreign object with an HTML object inside of our SVG. Internet Explorer is documented as not supporting foreign object, and it doesn't actually render it. But it turns out that despite not supporting it, they load external documents and run scripts inside it. So here's my test file. It's my same circle again, except this time down at the bottom, I've got my foreign object with XHTML, which has an HTML object in there. And then it loads the same file. But then before it loads, I have a JavaScript which pulls a integer off the query string, adds 1 to it, and then appends it to my link. If I render this in Firefox, I get an entirely sensible behavior. It recurses 10 times and then stops. I guess it decides that stop loading nested sub-resources at depth of 10. If I load it in Chrome, though, it's not quite so happy. On my test VM, which was a Windows VM with not a particularly huge amount of memory, it would run 241 iterations before the tab crashes. It looks like it's a Stack Overflow. If I ran it on a different system with more memory, it would run up to 1,000 iterations and it would stop at that point. So I'm guessing that I never got around to checking the code, but it looks like they're trying to cut off loading nested sub-resources at a depth of 1,000, which I think is excessive. And in some cases, the system runs out of memory or runs out of stack or something before it actually reaches that limit of 1,000. Internet Explorer is slightly more stable. It will load my nested subdocuments about 4,000, well, something in excess of 4,000 iterations on my test VM before its tab crashes. Now remember how I was saying that Internet Explorer will load static images inside static images. We can't run JavaScript in there, but what happens if we try to use a server-side script to change the link every time? So here I have a node.js script, which contains my circle again, except this time the circle's name is just a number, and at every load, I grab the number, increment it, and use that as the name for the new document. Load that in Internet Explorer. Even the latest DC1 build, it loads this thing something in excess of 250,000 times before it finally craps out due to what looks like memory exhaustion. So 250,000 times, that's reasonable. You're unlikely to have to actually be able to post a 250,000 attacker-controlled images on a different server. But if you want to try to do something unpleasant, like try to run up somebody's data plan bill, you might be able to use some trick like this. Now let's take an aside and talk about content security policy for a bit. Hopefully a lot of you are somewhat familiar with it. It's an exploit mitigation system. It lets the server define policies which restrict allowed sources for scripts, styles, images, and whatnot. So these resources can only come from whitelisted origins. It blocks mixed content, things like eval, inline scripts and styles, data URIs, and whatnot, unless overridden in the policy. And it's set by the server using content security policy headers, and these are enforced by the browser. So here's an example. First off, I set default source to none, which means that any policies that aren't overridden later on are defaults to not being allowed from any origins. Then I set script source and style source to self, meaning that scripts and style sheets are only allowed to be loaded from external files at the same origin. Inline scripts and styles aren't allowed. Then I use image source to restrict locations for images, the static images, to self, so that the same origin, data URIs, and one specific other origin, images.svg.test. Then I set object source and frame source both to self and images.svg.test. Since I didn't list media source, font source, or connection source, this policy would mean that audio, video, fonts, XHR, WebSockets, and stuff like that are not allowed on any origin. So this is sort of like ASLR in depth for web apps. It's pretty hard to get XSS in your web app if you have an SVG policy that requires you to only execute scripts from whitelisted static documents and eval is banned everywhere. I'm sure that once CSP becomes popular, somebody will find some clever way to work around it, but at the very least, it's going to make things an awful lot harder for attackers. Firefox and Chrome have supported it for a while. It's listed as in development, well, it's on the in development list for IE 12. Now, if you're responsible for maintaining web apps or web app frameworks especially, a lot of things like to mix content, scripts, and styles. So please get started on separating all that out so that we can use CSP in all its glory as soon as IE comes out with it. But the reason why I bring this up here is that CSP also applies to SVG. But there's bugs. None of this applies to IE because, as I said before, IE doesn't even support CSP at all right now. So here with Chrome, if I have an SVG that has inline CSS, and I load that with style source self in a static document context, so from an image tag or something, then it applies the CSS regardless of the CSP. For my example, I load the file in Firefox, the style sheet is rejected by CSP, but if I load it in Chrome, the style sheet is applied. Chrome also has an issue with how it handles frame source and object source. The standard for CSP is quite clear that frame source and object source apply to nested browsing contexts created using the object and embed tags. Object source applies to object and embed tags, and that frame source applies to nested browsing contexts created using iframe tags. So in my example here, I created a document that has both an object and an iframe, and I set the content security policy to object source self and frame source none. So allowed to load objects from the same origin and not allowed to load frames from anywhere. And if I load that in Firefox, I get what I expected. The object loads and the iframe is rejected. Chrome, however, rejects both. If I flip my content security policy around so that I have object source none and frame source self, again, I get what I expected in Firefox, where the object is rejected and the frame is loaded. And Chrome actually does the same thing. It behaves correctly in this case. Now, if I change my policy again and set object source and frame source both to self, then both browsers load both, as they should. So the issue here is that if I want to load an object or a nested context in an object tag or embed tag using Chrome, it has to be permitted by both object source and by frame source. Not exactly a vulnerability here, because what they're doing is they're being more restrictive than they should be, but it's still a bug. And they have another bug in Chrome with sandboxed iframes. The sandbox attribute in iframes involves a bunch of restrictions. It restricts script execution, but it doesn't say anything about restricting style sheets. So I have a document that loads an SVG with a style sheet. It's an external style sheet, of course, because I'm using CSPs that would block the internal style sheets. I load it in both a normal iframe and sandboxed iframe. Firefox behaves as expected. Chrome behaves as expected in the normal iframe, but it blocks the style sheet in the sandboxed iframe for whatever reason. And there's a number of other minor issues floating around out there. Firefox didn't apply CSP at all in sandboxed iframes prior to version 28, so that was fixed sometime around New Year. And it still doesn't work in the 24 ESR branch, although I think there's a new ESR branch that came out recently, so that's not really a big deal, or much of a big deal either. And this appears to have been due to some wider problems with permissions on sandboxed iframes rather than something specific to CSP. Now remember at the beginning I said that you could also drop SVG inline into HTML5. Now both Chrome and Firefox will display those inline SVGs, even if I use CSP to say that images are not allowed from anywhere. There doesn't appear to be an agreement right now between the CSP people and the browser people over whether an inline SVG is an image that should be blockable or whether it's something else that behaves in some other way. My position on that is that since inline images with data URIs can be blocked with CSP, then inline SVG should also be blockable. Although if you have a good argument on the other side, I'd like to hear it. And if you recall from before, when I was saying that Chrome was incorrectly loading cross-origin style sheets from static images, putting style source with CSP didn't affect that either. So the lessons to be learned from all of this, if you're using SVG for anything, is to treat SVG more like you would HTML rather than like how you would like any normal static image file like a PNG or a JPEG or whatever. If you're ever loading an untrusted SVG as an object or iframe, make sure it's not the same origin as other trusted content so that you can let same origin policy help you out. If you're loading the SVG as a static image, well then you don't have as many options because you can't use it on JavaScript and whatnot in it. But it's safer if there's untrusted content in there. Another takeaway from this is even today, browsers still have difficulty enforcing the basic browser security rules. And finally, CSP is your friend. Use it. Even if you can't use it right away due to legacy requirements, try to design new code to be CSP compatible. I know there's a lot of work in making everything in the web CSP compatible, but if every time there's a conference, some guy jumps around and does the Steve Ballmer monkey dance telling you how you need to use CSP, maybe people will slowly start picking up on it. And there's some future work, things I didn't get around to, and a bunch of references on SVG and CSP and the rules for static images and how to integrate SVG with other things in case anyone's interested. I have a white paper listed there, one that I'd linked earlier and skipped over, about best practices for CSP. That's for CSP 1. There's a CSP 2 that's also in development, which will expand on this and maybe correct a few of its deficiencies. And since I seem to have not run out of time, does anyone have any questions on this? No? Well, thank you very much for listening. Have a wonderful afternoon.